So the next set of operators we have to address are the logical operators. Java provides us with a total of 3 logical operators. You would see them here, the logical and logical OR and the logical NOT. Remember, when we talked about the bitwise operators, we also had the bitwise AND, bitwise OR, and the bitwise NOT. The logical AND has 2 ampersands put together. It's made up of 2 ampersands together. There's no space in between them. Meanwhile, the bitwise AND was just 1 ampersand. Same thing with the logical OR, made up of 2 vertical pipes, as opposed to the bitwise OR, which is just 1 vertical pipe. Then we have the logical NOT, which is an exclamation mark, but the bitwise NOT was a tilt. So we're going to look at these operators, then we'll look at one last one, which is the conditional operator. We'll also look at this in this video, the conditional operator, which is made up of the question mark and a colon. We'll see how that one works as well. So here we have the logical AND. The logical AND actually operates on it takes 2 operands, one on the left and one on the right, and it returns true if both operands are true. Actually, it works on Boolean. So if the expression on the left evaluates to true and the one on the right evaluates to true, then it's going to return true. This one returns true if one of the expressions, if one of them, either of them is true. If one is false and the other is true, it's going to return true. It only returns false when both of them are false. We're going to see that as well. And the NOT simply changes a true to false and changes a false to true. Now, in some other languages, you might use 0 for false and 1 for true, but Java will not allow you to do that. So with that said, let's go and write some code. I think the best way of seeing that is when you actually write the code. So to start, I'm going to close all of these. I don't need any of these. And I'm going to create a new class. And I'm going to call it logical example. That'll be the name of my class. And inside there, I'm going to write some statements. I would say int. Okay. Well, I'll not use variables. I'll use the digits directly. So I'll just put some statements here. If 4 is greater than 5 and 3 is less than 10, then ouch, so not correct. I need to create a method. Public void demonstrate, and all of that code will go inside there. So if I say this, I'll say system.out.println, and I would say the expression, or I'll say both expressions evaluated to true. And then down here, I'll come here, I'll say if, I'm not using any else statements here. I'll say, I'll just copy this. And I'll make sure this expression fails. Okay, this one is going to fail, this one is going to pass. So down here, I'll just do system.out.println, and I'll say both expressions did not evaluate to true. And then, okay, let's leave it at that, and let's demonstrate the AND operator, the logical AND. Remember, it's two ampersands put together. There's no space in between them. And let's look at this. Is 6 greater than 5? This is true. This part evaluates to true. And this is 3 less than 10. This evaluates to true. And this will produce, this will enter into this block of code. And then on this other side, we say, is 4 greater than 5? This is false. Is 3 less than 10? This is true. This one is false and this one is true. And because this one is false and this part is true, the AND operator will return false and will not get into this block of code. Something just came to my mind. Instead of demonstrating with those, I'm going to create some variables here. Boolean left is equal to true, and Boolean right is equal to false. Yeah, that's better. Let's actually see the true and false working together. So I'll say if left and right, then I'll get inside here and I'll say system.out.println both are true. Now let's run this. Because these expressions, one is true, one is false, so what happens? We said true and false. Because this is true and this one is false, the AND operator only returns true if both sides evaluate to true. But because one of them is false, right is false, it will not execute this block of code. So if I run this, ouch, I'm not calling my class, I'm calling some different class. Let me open this and I'll take this out and I'll create a new instance of my class, and my class is called logical example. LE is equal to new logical example, and I'll say LE dot demonstrate to call the demonstrate method. Now when I run this, you see I have nothing printed on the console, or I could go back there and I add another thing at the end there. So you see system.out.println. I am done. Now if I run that, you see that I have just one statement printed out. I am done. This one was not printed out because this evaluation, this expression evaluated to false. Why? Because this one is true and this one is false. So when we say true and false, it returns false, and that's why this was not printed out. You see only I am done, just this one, but it did not execute the if block. Now to change that, let's say I made this one true and I run it again. What happens? Whoa, you see now we have both are true. Because both sides evaluate to true, the logical AND evaluates to true, and we get into this block of code and it gets executed without any problems. Alright, that is set. Now if we decide to make all of them false, what happens? False, and then we make this one false too, and we run it again. You see I am done, and this block of code never executes. This block of code never executes because false and false will always return false. So we know that false and false always returns false. False and true always returns false. Only true and true will return true. So the AND operator, the logical AND operator, only returns true when both sides are true. Alright, so let's come back now to what we had down here. Control C. I'll comment that out, and then I'll take off this comment here by just highlighting and clicking Control C. Now we have some mathematical expressions here. We have 6 is greater than 5. Is this expression true? Yes, 6 is certainly greater than 5, and 3 is less than 10. So these will evaluate to true, and we're going to have both expressions evaluated to true. Now, down here, what happens? 4 is greater than 5. That's a very fat lie. 4 is certainly not greater than 5. So this evaluates to false. And then on this other side, 3 is less than 10. This evaluates to true. But because this is false, this expression fails, and this block of code, this expression returns false, and this block of code is not executed. So if we run this, we expect to see just this first part, both expressions evaluated to true, and this one, both expressions did not evaluate to true, should not be displayed because of this portion of the expression. And there we see it. This one executed correctly. It got into this block because this evaluated to true, this other side evaluated to true. But down here, 4 is not greater than 5. So this evaluates to false, and because of that, the whole of this expression here fails. This returns false, and we don't get it in this block of code. Now, there's one thing you want to note. Sometimes you will hear people referring to the logical AND as the shortcut AND, or the shorthand AND. The shortcut logical AND. That's what you commonly hear people calling it, shortcut logical AND. Why do they call it shortcut logical AND? It's based on the way it operates. Now, how this works is, if it evaluates, like we said, AND will only evaluate to true if both sides evaluate to true. So when it starts evaluating here, 6 is greater than 5. It evaluates this part and sees it's true, but it cannot make the decision. So it has to go and evaluate this part as well. So it evaluates this. It says 3 is less than 10. This evaluates to true. Now it can correctly, because this side is true and this side is true, it returns true, and we execute this block. But now look at where the shortcut comes in. The shortcut comes in here. It evaluates this. 4 is greater than 5. This has already failed. This returns false because 4 is never greater than 5. And because this has failed, the shortcut AND will only return true if both sides are equal. Because this has failed already, there is no need coming to evaluate this side, because even if it comes here, because of this first portion that failed, the result would still be false. So there's no need. From here, by evaluating this one and seeing it as false, the shortcut AND operator can correctly conclude that this evaluation is false, because one side has only returned false. So it will only evaluate the other side. It will only evaluate what is on the right if what is on the left first of all evaluated to true. If this evaluates to false, there is no need for this operator to come and evaluate this, and it's just going to jump in directly to the end because this has already failed. Now, that might not seem very significant, but when you have many lines, many expressions, many evaluations in your code, longer ones and so on, you want to use these little tricks to make your code perform a little faster. So you want to know, you want to be careful what expressions, I mean, if there's a probability that something is going to fail, you want to put that part first. Just a little hint. It might not be very significant, but it might still help boost your work a little. All right. That said, let's look at the OR operator. So I'm going to comment this back out. The logical OR. I'm going to comment this out. Then I'll bring this back in. Like I said, comment, you just do Control Shift C. If you're using another IDE than NetBeans, other than NetBeans, the shortcut for that might be different, and you have to verify. You have to check Google, and you would definitely get a solution. Now, the logical OR, which is two vertical pipes together, no space between them. What happens? It returns true if any of the sides is, if either or both of the expressions, both of these expressions, whether the one on the left or the one on the right, if any of them returns true, then the logical OR returns true. And sometimes you hear people calling it the shortcut OR as well, and we'll see why they do that. So let's start by running this. we say both are, well, the result or the expression evaluated to true. Now let's see what happens here. We have left is false, right is false. So what do we expect? We said this operator only returns true if at least one of the expressions, either the one on the left or the one on the right, returns true. So one or both of them must return true for this expression to be true. So because left is false and right is false, we don't expect it to execute this line. Instead, we expect it to jump directly to this. So if we run it, you see I am done, and it never executes this part. Now let's change one of them to true, and we run it again. Now you see, because one of them is true, because this part evaluates to true, but this one is still false, because one of them has evaluated to true, it gets in and execute this line before coming down. If all of them are true, it should still execute all the lines of code that we have there. So we can correctly conclude that we now see clearly that every time we use this operator, it will return true if either or both of the both sides are true. If the expression on the left evaluates to true and the one on the right evaluates to true, it returns true. If just one of them evaluates to true, let's say the left evaluates to true and this one evaluates to false, it's going to return true anyways. Now you would hear this being referred to as the shortcut logical OR operator. Why? Same thing like we saw with the shortcut logical AND. This one, it just needs one side to be true for it to make the decision. So if it checks here for the first time, for example, let's say this is false. If this is false, good. It cannot conclude that this expression will be false because it needs to come and check this side. It needs at least one of them to be true for it to return true. So if it evaluates this side and this side is false, it cannot conclude because it does not know whether this one is true. If it comes here, this one is true, even though this one was false, it still has to return true. So if this one is false, then it will continue and evaluate this other side to see if it's true or false. If this one turns out to be false, then it's going to return false. But if this one was false and this one turns out to be true, then it's going to return true. But now, if the first expression is true, let's change this to true. If the first expression evaluates to true, if this part, the left part, evaluates to true, because it only needs one side to be true for it to return true, there is no need for it to come again and evaluate this side. So immediately the first part, the left part, evaluates to true, the logical OR can conclude. It makes the decision at once and it goes ahead to execute this, and it does not bother executing this side again. And like I said earlier, you might want to use that to improve performance. Just note that as long as one side, if this left side evaluates to true, then we all understand that there is no need, because whether this one evaluates to false or true, as long as this one has already evaluated to true, it's going to get inside there. And that's exactly what the operator does. So I'm going to comment this out, and let's bring back what we had here. And I'll use the pipe. Now let's see what's happening here. I have the pipe here too. Let's see what's happening here. We're doing a comparison. Is 6 greater than 5? This evaluates to true, so it would simply go in there. Because it's the OR, it's simply going to go in there and execute this. Now if we come here, is 4 greater than 5? This evaluates to false, and that's the only time it will come and evaluate this part. But this one will also evaluate to true, and so we expect the two lines to be printed out. So if we run our program, we see both expressions evaluated to true. Well, I was supposed to correct this. Both expressions, at least one expression evaluated to true. You see, that's what we have here. And if I did this, for example, is greater than that, and I say 3 is also greater than 10, then we will see that this one will evaluate to true, but this one will not, because both sides here are false. But in this case, let's make one side false and the other side true. So you see that this side is true, this one is false, so it would execute this. But in this case, both of them are false, so it would not execute that. So we expect to see just this on the screen. And if I run that, exactly as we pointed out. All right. So remember, the logical OR operator would return true if either or both expressions, the one on the left and the one on the right, if either or both of them evaluate to true, then the logical OR operator will return true. It will only return false if both expressions evaluate to false. Now, the last logical operator that we want to take a look at is the NOT operator. I comment that out again, and I'll bring this back in. All right. Now let's look at the NOT operator. Like I said, the NOT operator simply turns true to false and false to true. So let's say we had a variable here, boolean done is equal to false. The job, sorry, system.out.println, the job is complete. And I'm going to do done. All right. Now, what is inside done? I'm just going to bring out some dashes here. What's inside done is false. Because this is false, this portion of the code should not execute, so we expect this line to be printed out. This one should be skipped because this is false. So if I run that, you see the only thing we have here are the dashes that I put in there. Now, the NOT operator simply changes true to false and false to true. So what am I doing here? I'm saying, what is the value of done first? The value of done is false. So I'm saying not false. If something is not false, it means it is true. So not simply changes false to true, and this is evaluated. This code inside the parentheses here, the curly braces, is evaluated. So if I run this again, you see now that because it was false, because done is false and I said not done, it flips that, it changes that to true. So the opposite, like you can say the opposite of false is true and the opposite of true is false. So the NOT operator simply converts that to its opposite. Okay, so we could also change this to true, and if we run this without the NOT operator, we expect it to get into this block. So if we run that, we see because done is true, this evaluates this is true, and we get inside here and we say the job is complete before printing this out. But we could apply the NOT operator on that, and it's going to invert that. It's going to change that to false because this is true and we said not true. It turns to false and this block of code will not be evaluated. And if we run that, you see that you just have the dashes. All right. With that said, I want us to look at one last operator for this video, which is the conditional operator. Now this is how it works. I'll put all this in comments and I'll just shift it down a little, and I'm going to write out something here. Like I said, we saw it earlier. This is the operator. So I'll put an expression here. 5 is greater than 4, and then this, and then it is true, and then here I'll say it is false. Sorry, I need to put that. It is false, and that ends it. I should probably do this. And I'll store the result. Oh, sorry. Oh, what am I doing? I'll store the result inside a string variable. String result is equal to that. All right. Or let me declare this on a different line. And I say result. So what am I doing here? I'm declaring a variable of type string. It's the same thing I could declare an integer. I'll show you an example with an integer. For example, let me write that to here. Int x. So I'll say x is equal to, I'll say maybe, well, I'll use the same expression. 5 is greater than 4, and then the question mark, and maybe 1, and then 0. Now, what this expression does, the conditional operator, this one, is like you're asking a question. Let me put this in parentheses so that we actually see the grouping. All right, it's like I'm asking a question here. I say, is 5 greater than 4? Question mark. So if this expression evaluates to true, the first value, this portion before the colon, which is 1, will be stored inside here. But if the evaluation, if this expression evaluates to false, then this one is returned. Same thing here. I said string result, and I say is 5 greater than 4. If this is true, then I expect this value, it is true, to be returned to this, and if it evaluates to false, then I should see it is false. So I'm just going to print out result here. Let's see what we get. System.out.println, and I say result. And maybe we do the same thing up here. System.out.println, and we say we print out x. So if I run this piece of code, this is what we get. Look at up here we have 1, and down here we have it is true. Why do we have 1? 5 is greater than 4, so this first portion is returned. This first portion is returned, and that's why we have 1 when we print out the value of x. So we say 5 is greater than 4. This evaluates to true, and this one is stored inside the variable x. Down here we say 5 is greater than 4. This evaluates to true, and it is true is stored inside the string variable result. Now if we change this and we change, let's change the sign down here. Here we are saying 5 is greater than 4, which is true, so the first value 1 should be stored here. But down here we are saying 5 is less than 4. We all know 5 is not less than 4, so this should evaluate to false, and instead of this getting stored here, now we are going to see it is false. If I change this first back to this and I run it, you see clearly that it is true because 5 is greater than 4. But let me change this back to this, and let's run it again. Now you see 5 is less than 4. It says it is false, this part. So because the expression evaluates to false, this first part is skipped, and then the second part here after the colon is returned into result. But for this one it remains 1 because the expression evaluates to true, and this first portion is returned, the first value is returned. If we change this to less and we run that again, we're going to have 0 now returned. You could do maybe greater than or equal to, and this should return true, or you could do less than or equal to, and it should return false. So you can use any operators there. any comparison operator. We saw the comparison operators earlier. You can, as long as your expression that you use here evaluates to true or false, this is going to work very fine. So we have now seen how the logical operators work. We've also seen how the conditional operator works. Like I said earlier, we're not going to talk about the instance of operator. We're only going to mention that when we talk about inheritance and when we start looking at polymorphism. We're going to talk about that there. The next set of operators that we have to deal with before we go on to other parts of our Java programming will be the assignment operators, and we'll be discussing that in the next video.